In this finite element modeling tutorial using ANSYS Workbench, we're going to look at the stresses that develop around a hole in a plate when the plate is pulled in the axial direction. So our plate will be 4 inches in width and our hole is 1 inch in diameter. So after opening ANSYS Workbench, I'll go to File, Save As, and enter plate with hole as the file name and save it in a directory where I know I can access it. Then I will come to Analysis Systems, click on the plus sign to open up the drop down, click on Static Structural, drag and drop it into the green box, and I can also change this to plate with hole. I now need to address each of these items listed in this window. Engineering data has a green check by it indicating that there has been a material selected. I know the default is structural steel. I want to also possibly look at this plate as an aluminum plate. So I'm going to double click on engineering data. To add aluminum, I will come to engineering data sources and click on it. Then I will click on general materials. I'll scroll up to an aluminum alloy and I'll click the plus sign. The book here indicates that that has been added. So I now have added aluminum alloy. I'll back out of this by clicking Engineering Data Sources and back out of Engineering Data. The next task is to do the geometry. This is done in SpaceClaim. So by double clicking on geometry, I can see that down here it says it's starting SpaceClaim and I have the red indicator saying that the software is busy. After opening SpaceClaim, this is the window that you will see. The first thing I like to remember to do, if I need to, is change the units. So to change the units, you come and left click on File, come down to SpaceClaim Options, and it opens up this dialog window where you go select Units. Then if you want to change the units for just this document, you can leave the default here, or if you want to change the default settings, you can click on the drop down and select all new documents. Then to change to English units, click the drop down on type and change metric to imperial. You can also come to length and change the default length from inches to feet or mils, any of these choices here that you would like. I will leave it in inches. And then I scroll to the bottom and the default grid spacing is 1/8 of an inch with 8 spacings per major spacing. I like to change this to 1/10 of an inch, so click on it and type in 0.1 and then change this to 10. Then I click OK and I have changed my units. The next thing I like to do is I like to sketch in the XY plane, and the default is to show you and let you start sketching in the XZ plane. The reason I like the XY is because that's the default for ANSYS Mechanical. So if you right click, it opens this pop-up window and you can left click on Select New Sketch Plane. When you do this, you can select any of the 3 sketch planes. Here I show the XY. If I move my cursor down here, I have the XZ again. If I move my cursor into the YZ plane, I now have the YZ plane. So I can scroll through and select any of these planes. When you have the one that you want to sketch in, just left click and it selects that plane. Now I'll come up and I will hit Plan View and orient my drawing with the Z-axis coming out at me. Across the top here in SpaceClaim are all the different tools that you have to help build the structural model. Most of what you will do is in Design, Measure, and Prepare. In the Design tab, you have the commands here to orient your structure. Then you can build your sketch. This is where you can select circles, rectangles, or lines, or curves. Then you come over here and you will edit it with these commands. And here's where you select the mode. So we're in a sketch mode, and then we can go to 3D mode when we're ready to start to pull things into 3D geometries. One nice thing about Space Claim is that if you hover over the icon, it will pull up and tell you what that icon does in pretty detailed information. And then also you can see where it says press F1 for more help. So for example, if we're concerned about drawing a line and I need more help, I can highlight this. I'll press F1 on my keyboard and it will pull up an additional help on your ANSYS internet web page. So pulling over my ANSYS so that you can see it, here's what will come up, and it tells you to draw lines on a sketch plane, click line, and goes through and gives you the details of how to draw lines. So it's a very handy help tool. So I'm ready to sketch a rectangular piece with a hole in it. To do that, I will come back to Design. I'll go to Select, and now I'll click on my rectangle. Over here, when you click on one of these items to sketch, it pulls up an options window, and you have several different options that you can pick. For example, here I want to define my rectangle from the center, so I'll click that option. Now when I come over to define my rectangle, I can left click on the center and click and drag, and you can see the dimensions of the rectangle are given. The highlighted blue dimension are dimensions that I can type in, or I can expand it out. In this case, it doesn't really matter how long my model is. That dimension wasn't specified. So if I want to make it 5 inches, I can stretch it out to 5, or I could have it down at some other number and type the number 5 and then hit enter, and it would make it 5 long. When you hit enter, it automatically jumps to the next dimension, and this dimension was 4, so I could either stretch this dimension or I will simply type in 4, enter. Now you can see that my model is not centered about the origin, and that's because I hard-coded in these dimensions. So if I want to delete this rectangle and start over, what I do is I come over to curves, and I can select the curves, and I can select all of them, and I can right click on curves and hit delete, and now my rectangle is gone. So to do my rectangle over, I'll come back, rectangle's highlighted, I'll define from the center, I'll click on the center and I'll drag it out, leaving my finger on the left mouse button. I will type in a 5, and then I hit the tab command, the tab button on my keyboard, and it will go to the next dimension where I can type in 4 and then hit enter, and I now have my rectangle and it is centered about the origin. You can see here that all these lines are defined under curves. To create my circle, I'll come up and click on circle. I'll come to the center, click on the point, and with my left mouse button drag it out. You can see there the diameter signal, and it says the diameter is 1.98, or I can drag it to whatever I want it to be. I want my diameter to be 1 inch, so I'll simply type the 1 in and hit enter, and there is my 1 inch circle. And I now have my plate defined with my hole in it. And I'm ready to move on and make this a 3D model. So what I will do is come to mode and select on 3D mode. And when I do that, you can see that the geometry changes and I lose my sketch screen. I can push down my middle mouse button, my roller, and I can rotate my object around. If I hit Control and my middle mouse button, I can translate my object. So now we're going to use the pull command in SpaceClaim. To use the pull command, what it'll do is it'll take a surface and pull it out into a third dimension. So to pull my plate, I'm going to click on this surface, and you can see the yellow arrow highlighted here. That means I can pull my surface in this direction or back here in this direction. And you can see that I could enter a number as to what dimension I would like to pull my surface in. You can see that right now it's leaving the hole in the plate. If I wanted to pull the plate as a whole, I can simply select Escape here, and now I can select both areas by hitting Control Select and doing multiple selects. Now I have multiple areas selected, and when I pull them in directions, it will pull the whole block as a solid. Again, I can hit Escape to get out of that. Now I can come back and go to Select and just select the one surface, then go to Pull, get on the arrow and pull it in the direction, and I'll pull it a half an inch. So I'll type in 0.5, enter. And now I have my plate. It's oriented about my XY plane, and I can push down my middle mouse button and rotate it around and see my plate. If I needed to check any dimensions to make sure I got them right, I could come up and click on Select, and then come to Measure, and then hit Measure in the Inspect tool, and I can come and highlight the length of that line, for example, and it will tell me that the length of the line is 0.5 inches. I could come and pick on this circle, and it'll tell me that the circle diameter is 1 inch, and then it'll give me the perimeter. I can also click on this line, and it would give me the length of that line. So when you get a more complicated geometry, it's often very nice to be able to check your dimensions, and you do that with the Measure tool. So coming back to Design, I can click on Select, and my geometry is completely designed. Over here I can see that I have one solid and one surface. Since this surface is not important to my finite element model, I am going to right click on the surface and delete it so that it does not get pulled into ANSYS Mechanical and have Mechanical think that I'm trying to mesh that. So now all I have is this one body. If I had multiple bodies, I could come over here and unclick that body, and it takes it so that you can't see it. And if you want to activate it again, you simply need to click on the box and you'll see it again. It's now a good thing to save this geometry, so I'll come to File, Save As, and I'll save that in where I've been saving these files in the right directory, and I will put Plate with Hole. And this will save it as a SpaceClaim file. It's an SC.doc file, and I can hit Save. Now I'm done with that. I usually just minimize this so that if I need to open it or modify my geometry, I can do it without opening SpaceClaim again. So I minimize this window, and I'm ready to come back to my ANSYS project schematic page, and you can see now that I have a green check by geometry, meaning that I now have the geometry completed in an acceptable geometry that is understood by ANSYS. So now I'm ready to go to Model. I'll double click on Model. You can see down here in the corner it says Starting Mechanical. So when ANSYS Mechanical opens, you'll see your geometry in the geometry window. We can move this geometry by holding down the control button and our middle mouse button, and we can move the geometry on the screen. We can zoom in and zoom out by scrolling our middle mouse button, and we can rotate the geometry by clicking the middle mouse button and rotating the geometry. You'll note that wherever the cursor is when you click your middle mouse button to do the rotation becomes the point of rotation. Up along this toolbar here we have some nice features. We can zoom in and zoom out, but we can click this button and it will fit the structure to the size of the window and orient it again. That is a very handy feature when you get a complicated geometry. We note down here that on our scale we're going from 0 to 0.07 meters. We want to work in units of inches, and so I need to come up to the Home tab, come across and left click on the units drop down and change from metric to US customary inch pounds. Now my scale has been changed from 0 to 2 inches, and you can see that scale change as you zoom in and out. I now look at my project window and my project tree. I have a green check mark by my geometry, which indicates that ANSYS believes I have a good valid geometry. If I click on the plus sign, I can see that my geometry consists of one solid in this system. If I click on that, I can see the details of this system solid down below. I can see that under material the assignment is structural steel. If I left click on that box, it'll bring up a drop down arrow that I can click, and I could change the material to aluminum or any other material that I had added as we showed previously. I want to leave it as structural steel, so I'll just click again and then close this box, and I'll leave it as structural steel. I can now minimize the geometry. Under materials, we had two materials selected in this model, structural steel and aluminum alloy. I can double click on structural steel and it brings up the window showing the material properties that have been assigned to structural steel. So I can quickly go back and look at the properties that I have assigned, and I could go back and change them if I needed to. I can then minimize the materials drop down. We won't do anything with coordinate systems or connections in this tutorial, but we will in future tutorials. If I come back up and click on geometry, it will show my geometry again. Now I'm ready to break the system into elements and nodes, and I do that through meshing. So if I click on mesh, I can come up and click the solve. This pink mesh appears because that's a previous mesh that I assigned to this particular geometry, and it indicates, a pink mesh indicates that it needs to be updated. So I will come up and click on mesh, come to the top, click on mesh, come over and click generate. Down here you can see that it popped up and showed the work progress. It was so quick because this is quick, and you can see your mesh. This mesh would probably be fine, but I'm really interested in the stresses around this stress concentration, so I want to refine the number of elements or the size of the elements right around this circle. To do that, I come to mesh, I come across the top to refinement. I left click on refinement. It brings up a refinement window, and it highlights that I need to select the geometry. If you have a yellow box over here under this drop down, it implies that it is waiting for information. So I'm going to come across the top here and use the selection guide. I want to select lines, so I'll select that icon, and that lets me just select lines. I can come and as I get on the line, it highlights it. I can click it, and then I can control and move to the back line and click that. I now have those two lines selected as shown by green. I can come over to no selection and left click on it, and then left click again and apply, and it now says I have two edges where the mesh has been refined. I come down to the refinement, I click on the 1 box, and I'll increase that to a 3. Now if I come up and click on Update Mesh, you can see it's thinking about it. It did it quickly. If I click on Mesh, now I have my refined mesh, and I can see that the number of nodes and elements around the circle have been increased. If I wanted to increase them more, I just come back to Refinement and click on it again and refine those. However, that mesh is acceptable for what I want to do for this problem. I'm now ready to apply boundary conditions and the forces. I do that under static structural, so I'll click on static structural, and it brings up this environment window. The main tools that you'll use here are this loads group and this boundary conditions group. And so under loads, I'm going to apply a force, and I'm going to apply a force on this face. So I'll come up and select the face selector tool, select this face, come over, click apply under geometry, and now I need to set the magnitude of that force. Here I don't want to define it as a vector, I want to define it in components, so I'm going to click on the define by box and then click again to bring up the drop down, left click on components, and now I can enter in the XYZ components of that force. In the X box I'll type 100 pounds, enter, and 0 pounds in the Y and Z. I'm now going to come over and fix this edge of the plate. So I'll come up to my boundary conditions box, click on fixed, click on this face, left click apply, and it tells me that I now have a fixed support on that face. So if I want to review my model, I can come over here and click on force. It says I have a force of 100 pounds. The components are 100, 0, and 0, and it's on this face pulling in that direction. I can look at my boundary condition and my fixed support. It tells me I have a fixed support on the purple face, and this face here is shown in purple. So I now have my loads and boundary conditions applied. I'm ready to tell ANSYS what I would like to see as results. I do that under Solution, so I'll click on Solution. It brings up this row of tools that I can select from. I'll look at the total deformation. I'll come and I'll look at the stress, and I'll look at the von Mises equivalent stress, and I could also look at a shear stress. You can see that these gold lightning bolts mean that this has not been solved, but there are no question marks indicating that more information is needed. So it is ready to go through the solution process. I'll come up and simply click on Solve. Down here you can see the solution process as it takes time, and it goes pretty quickly. Right now it's showing me the last item that I selected over here was shear stress. That's the shear stress in the plate. If I look at equivalent stress, here's the equivalent stress, and you can see that I have some stresses develop on this boundary because it's holding all of those points fixed, and as I pull on this force, the plate would want to narrow down. You can see by far the majority of the highest stresses are where they would be expected in pulling on this plate. I can also look at total deformation, and my deformation is largest out. ANSYS also has some nice tools to look at the details of the mesh. I can come up here under Results, click on Select Section pane, and then this essentially is a section line, and I can left click and draw a line down through there and cut the body in half. Now I can middle mouse button scroll around, and I can look at the stresses. I can scroll in And now I can come over and come to probe along the top, click on probe, and you can see that as I move my cursor around on the different nodes and elements here, it indicates the stresses on those elements. If I want to delete that, I come over here to sections planes, click on it, click the X to delete it, and now I'm back to a full body mesh.